Alright, this is the second video on complex numbers or imaginary numbers. And when we have something like this, 3i, again 3i is the same as the square root of a negative 3. This term right here is what is called a pure imaginary number. And on future videos I'm going to refer to that when we start talking more specifically about what is a complex number. But you'll hear me refer to that as a pure complex number. And in this next problem, we're going to have an equation, y squared plus 20 equals 0. And first of all, I'm going to graph this. I think I'm going to graph this y squared plus 20 as x squared plus 20 equals y. And I'm just going to rewrite it in this form to get it look like that. I'm going to go to my calculator and graph it. And I want to show you what it looks like and talk about the context of this, because I think that's important to have. And so I'm going to go to graph, and I'm going to get rid of this. And I'm going to put 5x squared plus 20. Execute, and I'm going to make sure my window is correct. And I'm going to go to a standard window, and I'm going to draw. And where is it? Okay, so if you take a look at it, it's way up here. And so the vertex is at 0, 20, and then it goes up. And so this is a graph in which there are no x-intercepts, right? When we have no x-intercepts, that means we have imaginary solutions. And so when we have the square root, and inside that square root we have negative values, we know we have what we call no real solutions. What we really have is imaginary solutions, or pure imaginary solutions. And that's some things we are going to talk more about down in the future. Alright, so let's go back to this, and I'm going to solve this. And again, it was 5y squared plus 20 equals 0. I'm going to subtract 20 from both sides. And I get negative 20. And then I'm going to divide both sides by 5. And I'm going to get negative 4. And now I'm going to take the square root of it. And when I do that, it's going to look like this. I've got that square root symbol. But anytime you have a variable that's squared and you take the square root, outside here it is saying there are two values, a positive value and a negative value. It's kind of like this. You've done problems for today that said x squared minus 4 equals 0. And you write x squared is equal to 4, and then you came up with the answer and you said plus or minus 2. And if you put 2 in here, 2 squared minus 4 is 0, but a negative 2 squared, which is 4, is also equal to 0. So I could have put an in-between spot here that said plus or minus the square root of 4, and then my next step would look like this. So there's this symbol here that says you have two answers, one a positive and one a negative. Well, this means the same thing. And it's because this variable is being squared that I need to put this symbol in front of the square root symbol. So if I continue, because I have a negative inside the radical, or inside the square root, I'm going to write plus or minus I times the square root of 4. And the square root of 4 is a perfect square, so I'm going to get plus or minus I times 2. Now the way we write that is we're going to write that as plus or minus 2i. And that's my pure imaginary number. There are two of them, a positive 2i and a negative 2i. And if I put them both in here, if I would square 2i, I would get 4 times I squared, and that would be 4 times a negative 1, and I would get a negative 4. And if I took a negative 2i and squared it, a negative 2 squared is 4. I squared is a negative 1, and again I'd get that negative 4. And so you can see here I'm going to have those two different types of coefficients. Alright, let me do one more. And let me have 6x squared plus 300 equals 0. So I have 6x squared is equal to a negative 300, and I get x squared is equal to negative 300 divided by 6 is a negative 50. And so that means x is going to equal, notice my plus or minus sign in front of the square root, a negative 50. So my first step is to draw out or bring out that negative symbol as I. I have the square root of 50. Now, is there a perfect square that exists in 50? Well, yes, there is. 25 does. So I'm going to rewrite it like this, times the square root of 25. 25 times what is 50? 2. Now, I'm actually going to figure out the square root of that. And so I'm going to have x equals plus or minus, what's the square root of 25? 5. The I comes second, and then the square root of 2. And those are my two answers.